Good morning, students. This is Latif sir. In this video, I am going to start the chapter 4 of class 10 chemistry. The topic is analytical chemistry. From this chapter, you have to read all the topics. Okay, so this is the chapter 4 of class 10 chemistry, analytical chemistry. So first, in the introduction part, it is given color of different salt and their solution. Generally we know that transition elements are colored. Transition elements, that is elements of group 3 to 12 in the periodic table, they are generally colored. Transition elements like iron, chromium, copper, these are transition elements. Okay, and generally representative elements, that is elements of group 1 and 2 and 13 to 17 are colorless. We know that. Okay, so transition elements are generally colored, and color of different ions, different ions are given here. You can see color ions and colorless ions. First one is colorless ion and second one is colored ion. Ammonium ion, which is colorless. Sodium, potassium, these are calcium, these are representative element. Okay, calcium, magnesium, lead, zinc. Zinc and lead are transition element, and sodium, potassium, calcium, magnesium, calcium, magnesium, these are representative element, and they are colorless. Okay, some anions are also colorless, like anions like chloride, sulfate, carbonate, nitrate, hydrogen carbonate, sulfide, all these are colorless anion. Now see which are colored ion. Which metal ions are colored? Metal ions like cupric Cu2 plus, which is blue colored. Ferrous ion, that is Fe2 plus, which is light green color. Ferric ion, that is Fe3 plus, which is yellowish brown color. Nickel ion, that is Ni2 plus, which is green color. Chromium ion, that is Cr3 plus, which is pink green color. Okay, and manganese ion, that is Mn2 plus, which is pink color. And all these colored ions are transition metal elements. Okay, and now see some anions are which are also colored, like potassium permanganate or permanganate anion, MnO4 minus anion, which is pink colored, pink or purple. Okay, dichromate Cr2O7 2 minus, which is orange colored. Chromate ion Cr042 2 minus, yellow colored. So you have to remember the color of different metal ion and color of different anions given here from this table. You have to remember. Okay, and second topic of this chapter is you have to read the action of sodium hydroxide and action of ammonium hydroxide on certain metallic salt solution. Action of sodium, that is sodium hydroxide, that is NaOH, and action of ammonium hydroxide on certain salt solution. Salt solution like salt of calcium, zinc, lead, iron. This action of sodium hydroxide on this salt solution, salt of calcium, calcium, iron, zinc, lead. Okay, so first one is this is the general scheme of this reaction. When a salt solution is treated with alkali like sodium hydroxide, you will get a metal hydroxide precipitate. Okay, like sodium hydroxide, metal hydroxide precipitate, and a salt solution, you will get a salt. Okay, this is the general general scheme of this reaction. Action of alkali one different salt solution, and you have to remember the observation also. Okay, so color of the precipitate and its solubility in excess of alkalis. Okay, so first type of salt is calcium nitrate, CaNO3 whole twice. When calcium nitrate is treated with sodium hydroxide solution, you will get a white precipitate of calcium hydroxide and colorless sodium nitrate solution. Okay, and this white precipitate of calcium hydroxide solution, color of, and the color of this white precipitate of calcium hydroxide, which is sparingly soluble. sparingly soluble in excess sodium hydroxide. Okay, next type of salt is iron, salt of iron, that is ferrous sulfate and ferric sulfate or ferric chloride, here it is given. So when ferrous sulfate, that is FeSO4, in ferrous sulfate Fe2 plus ion is present. Okay, so when ferrous sulfate is treated with sodium hydroxide or caustic soda solution, you will get a gelatinous, dirty green gelatinous precipitate of ferrous hydroxide, FeOH whole twice, and sodium sulfate. You will get a dirty green gelatinous precipitate of ferrous hydroxide and sodium sulfate. Okay, so Fe2 plus ion on treatment with caustic soda, it gives gelatinous, dirty green gelatinous precipitate, and this dirty green precipitate is insoluble in excess sodium hydroxide. You have to remember both the reaction and observation. Okay, now see, when ferric ion, ferric salt, that is FeCl3, Fe3 plus, when ferric salt is treated with caustic soda solution, that is NaOH solution, you will get precipitate, reddish brown precipitate. You will get reddish brown precipitate of iron 3 hydroxide, that is ferric hydroxide, FeOH whole thrice. You will get a reddish brown precipitate of ferric hydroxide and sodium chloride, and this reddish brown precipitate is insoluble in excess sodium hydroxide. Now reaction of copper salt, that is copper sulfate with sodium hydroxide solution. When blue colored copper sulfate solution is treated with colorless sodium hydroxide solution, you will get a pale blue precipitate of cupric hydroxide, CuOH whole twice. CuSO4 plus 2NaOH implies CuOH whole twice, a pale blue precipitate, and sodium sulfate, which is colorless salt. Okay, and this pale blue precipitate, which is insoluble in excess sodium hydroxide. Now see action of sodium hydroxide on zinc salt. For example, when ZnSO4 colorless zinc sulfate is treated with sodium hydroxide, caustic soda, you will get a white gelatinous precipitate. You will get a white gelatinous precipitate of zinc hydroxide. Okay, so when zinc sulfate is treated with sodium hydroxide solution, you will get a white gelatinous precipitate of zinc hydroxide and sodium sulfate, and this white gelatinous precipitate of zinc hydroxide, which is soluble in excess sodium hydroxide. Okay, now see in case of lead salt like Pb salt, in case of lead Pb, in case of Pb2 plus ion salt, when Pb2 plus ion salt of Pb2 plus ion, that is PbNO3, is treated with sodium hydroxide solution. When salt of PbNO3 whole twice is treated with sodium hydroxide solution, you will get a white PPT of lead hydroxide and sodium nitrate, which is colorless in solution. Okay, so Pb2 plus ion salt gives white precipitate with sodium hydroxide solution, and this white precipitate of lead hydroxide, which is soluble in excess sodium hydroxide. Okay, now see action of sodium hydroxide on ammonium salt, that is NH4 plus ion. Okay, ammonium salt like NH4Cl, NH4 whole twice SO4. When these ammonium salts are treated with sodium hydroxide solution, you will get salt, water, and ammonia. Okay, so when sodium hydroxide is heated with ammonium salt, you will get ammonia gas. Okay, and the smell of ammonia is pungent. You know that this is the identification test of ammonia gas. Okay, so when ammonium salt, that like NH4Cl or NH4 whole twice is heated with caustic soda or sodium hydroxide, you will get ammonia gas and salt like NaCl or Na2SO4 and water. Okay, Now see action of ammonium hydroxide. Action of ammonium hydroxide. This is the action of ammonium hydroxide on certain salt solution. Okay, that is action of NH4 action of ammonium hydroxide NH4OH on different salt solution. Okay, so when salt solution is treated with ammonium hydroxide, you will get metal hydroxide and salt formed in solution. This is similar to sodium hydroxide. Okay, but some observation are different from the previous case. Okay, and you have to remember the observation also. So when calcium salts when calcium salts when calcium salts are treated with excess ammonium hydroxide, you will get no precipitate. Okay, but when calcium salts are treated with sodium hydroxide, you will get a white precipitate. Okay, when calcium salts are treated with sodium hydroxide, you will get white precipitate of calcium hydroxide. So this is the differentiation between between ammonium hydroxide and sodium hydroxide. Sodium hydroxide gives white precipitate with sodium hydroxide gives white precipitate with calcium salt, but ammonium hydroxide does not give any any precipitate. Okay. Next, treatment of iron salt with ammonium hydroxide solution. When iron 2 salts like FeSO4, when iron 2 salts like FeSO4 is treated with ammonium hydroxide solution NH4OH solution, you will get dirty green precipitate of iron 2 hydroxide FeOH whole twice, similar to sodium hydroxide. Okay, so when iron 2 sulfate FeSO4 is treated with ammonium hydroxide NH4OH, you will get dirty green precipitate of iron 2 hydroxide or ferrous hydroxide and a colorless salt ammonium sulfate. Okay, and the dirty green precipitate is insoluble in ammonium hydroxide, excess ammonium hydroxide. And when iron 3 salt like ferric chloride or ferric sulfate, when iron 3 salt like ferric chloride or ferric sulfate is treated with ammonium hydroxide salt, you will get a reddish brown precipitate of iron 3 hydroxide. You will get a reddish brown precipitate of iron 3 hydroxide and ammonium chloride, colorless salt in solution. And this reddish brown precipitate is insoluble in excess ammonium hydroxide. Now see action of ammonium hydroxide on copper 2 salt. Action of ammonium hydroxide on copper 2 salt. Okay, so when copper 2 salt like copper sulfate, blue color copper sulfate is treated with ammonium hydroxide, you will get a pale blue precipitate and ammonium sulfate. Okay, and now see when excess ammonium hydroxide passed, this pale blue precipitate soluble in excess ammonium hydroxide and forms deep blue solution. Okay, so when copper sulfate first treated with ammonium hydroxide, first you will get a pale blue precipitate, and this pale blue precipitate of copper hydroxide which is soluble in excess ammonium hydroxide. Okay, and this pale blue precipitate that is this pale blue PPT, that is CuOH whole twice copper hydroxide, reacts with excess ammonium hydroxide. Reacts with excess ammonium hydroxide and forms a deep blue solution due to formation of CuNH3 whole 4 SO4 plus 2H2 due to formation of this compound tetraamine copper 2 sulfate. Due to formation of this compound, the pale blue precipitate soluble in excess ammonium hydroxide and forms deep blue solution. Okay, so reaction is also given here. You can see any one reaction you can read. Okay, and this reaction is characteristic property of copper 2 plus ion, and it is used for its detection in qualitative analysis. Okay. Now see action of ammonium hydroxide on zinc salt. When zinc salts are treated with ammonium hydroxide, it forms white gelatinous PPT and ammonium sulfate. When ZnSO4 is treated with ammonium hydroxide NH4OH, you will get gelatinous white precipitate. Okay, and this gelatinous white precipitate is soluble in excess ammonium hydroxide. Okay, so the reaction in excess ammonium hydroxide initially produced zinc hydroxide precipitate, white gelatinous precipitate, reacts with excess ammonium hydroxide and it forms tetraamine zinc hydroxide and water. That is the initially formed gelatinous white precipitate which is soluble in excess ammonium hydroxide. And the last salt is lead salt. Lead salt like lead nitrate. When treated with ammonium hydroxide, it forms white precipitate and ammonium nitrate, and this white precipitate, chalky white PPT of lead hydroxide, which is insoluble in excess ammonium hydroxide. All these reactions with observation you have to remember. Okay. Now here action of alkali on certain metals is given. Action of alkalis like NaOH, KOH on certain metals. Okay, not certain metal salt. So here you have to read about action of alkali like sodium hydroxide, potassium hydroxide on certain metals like zinc, aluminium. Okay, and you will get salt and hydrogen. So when zinc Zn is treated with sodium hydroxide, you will get sodium zincate Na2ZnO2 and hydrogen gas. Similarly, when zinc is treated with hot concentrated potassium hydroxide, you will get potassium zincate K2ZnO2 and hydrogen H2. Now see action of sodium hydroxide and potassium hydroxide on aluminium. Okay, so aluminium reacts with boiling caustic alkali solution. Aluminium reacts with boiling caustic alkali solution like that is Al plus NaOH plus water. It forms sodium meta-aluminate NaAlO2 and hydrogen gas. Okay. Similarly, aluminium reacts with boiling caustic soda solution and it forms potassium meta-aluminate and hydrogen gas. And aluminium reacts with fused alkali like fused NaOH to produce sodium aluminate and hydrogen. Sodium aluminate, that is Na3LO3 and hydrogen. Okay, so aluminium can react with sodium hydroxide in two different ways. When aluminium reacts with boiling caustic alkali solution, you will get sodium meta-aluminate and hydrogen. And when aluminium reacts with fused alkali, it will produce sodium aluminate Na3LO3 and hydrogen. So the reaction is Al plus 6 NaOH, 2Al plus 6 NaOH implies 2Na3AlO3 plus hydrogen 3H2. Now see action of sodium hydroxide and potassium hydroxide on lead salt and on lead. Okay, so when Pb is react with when lead is treated with sodium hydroxide, Pb is treated with sodium hydroxide, you will get sodium plumbite Na2PbO2 and hydrogen gas. Similarly, when lead is treated with potassium hydroxide, you will get potassium plumbite K2PbO2 and hydrogen gas. Okay, so all this reaction you have to read. And last topic of this chapter, it is given action of alkali on metal oxide. Metal oxide like sodium oxide, zinc oxide, aluminium oxide. Action of alkalis, that is NaOH, KOH on this metal oxide. Okay, so, and there are some metal oxide which are acidic oxide like carbon dioxide, sulfur dioxide. Some oxides like sodium oxide, magnesium oxide, calcium oxide, these are basic oxide, and some oxides are amphoteric like zinc oxide, aluminium oxide. These are amphoteric oxide. Okay, so first see the scheme of this reaction. Which are amphoteric oxide? Amphoteric oxide are those oxides which can react with both acid and alkalis. Okay, so some example of amphoteric oxide, some examples of amphoteric oxide are zinc oxide, aluminium oxide, okay, and lead oxide. So action of sodium hydroxide and potassium hydroxide on this amphoteric oxide you have to read. When amphoteric oxide like zinc oxide or zinc hydroxide is treated with sodium hydroxide, you will get a colorless soluble sodium zincate and water. Okay. Similarly, when zinc oxide is treated with KOH, you will get potassium zincate and water. And now see action of sodium hydroxide on aluminum oxide. Aluminum oxide is also amphoteric. Okay, so when aluminum oxide is treated with sodium hydroxide solution, you will get sodium metaluminate and water, NaAlO2 plus water. Okay, and when lead oxide, when lead oxide PbO, very important reaction. When PbO, lead oxide, which is yellow in color, when lead oxide is treated with sodium hydroxide or potassium hydroxide, you will get a colorless soluble salt sodium plumbite K2 Na2PbO2 or K2PbO2 and water. Okay, so yellow colored lead oxide when treated with sodium hydroxide or potassium hydroxide, it forms a colorless soluble salt sodium plumbite or potassium plumbite and water. Okay, so in this chapter many chemical reactions are given. Okay, you have to read all the chemical reaction, and I have told that zinc oxide is amphoteric oxide. It can react with acid like ZNO can react with HCl to give ZnCl2 and water, and it can also react with sodium hydroxide, which is a base, NOH, to give sodium zincate and water. So zinc amphoteric oxide can react with both acid and bases. Okay, so mainly this reaction in this chapter main thing is you have to remember, or you have to practice all the chemical reactions, and at the same time you have to remember the observation of each type of chemical reaction. Okay, and this chapter is completed. Thank you, students.